Alright, I'm back everyone. I've been away for a little while. I was testing 5.6, testing some new stuff on Voxel plugin, and then I had a holiday in Slovenia, which was nice. And what I'm going to start on today is points of interest. I'm going to split this into two videos. I'm going to split it into one video showing you about the data tables and structures behind the points of interest, which I might even split it into three videos. Second video will probably cover the PCG graph for placing points of interest, and then a third video on PCG data assets and how you create them, or how I'm going to set up a system to create them. Because we'll effectively be creating a bunch of different levels for each point of interest, so that they can be updated as things change with them, like artistically. And we'll also need to customize them to get a bit of different data out in PCG than the default PCG data asset exporters have available. I've done all of this work, so I'm mostly just going to be walking through it. It's not easy to record it as I'm building it the first time, and some things I don't want to rip out and build again. So here we are, it's just going to be a walkthrough. All I've got at the moment is the first point of interest, the starting stones for the Valheim world. And then I've got two other examples. One is, well, actually, I think I've got three other examples, but it's just a couple of static meshes. It's nothing complex. It's just to test out the scattering. But let's get into it. So in my MISC folder I have two new folders, one for biomes and one for points of interest. The biomes folder contains an enumeration for the biome, a structure for the biome data table, and the biome data table itself. So my enumeration is just all of the biomes that we're using. The biome struct is for the data table. It's a very simple biome struct. It's just an enum value from that enumeration we've just created and the color that is being applied to the terrain in a voxel graph. And then the data table itself is that data altogether. I've renamed the row names as well. These colors I've manually copied and pasted from the voxel height graph. Pardon me. Because there's no better way to do it right now. So if I ever change the color of the terrain, I'll need to come in here and update this as well. And then points of interest. I'll have a file later on for the PCG data assets, but at the moment all we need is the POI struct and the point of interest table. Just to have a look a little bit at points of interest in Valheim, gone to the Valheim wiki. The list of biomes available is, it's more or less a data table really, with a bunch of different parameters. So it's listed, so we can see up above actually, it's listed in the order that they are distributed currently. Can't remember where it says that, but it does somewhere on this screen. And then we've got some default data for what points of interest need. So they need an altitude, they need to specify whether they have a random or a fixed rotation. The terrain delta is basically the normal. Is it on a slope? Vegetation, uniqueness, or etc. But then you look at this table and it's got things like whether a point of interest must be in a specific biome, how many there can be, how close it can be to similar points of interest, altitude. I don't know what this forest 1 to 5 is, but then you get things like maximum distance, distance ranges, the maximum slope it can be on, the size of the point of interest, whether it's prioritized, whether you're allowed to build, whether it's damaged, whether there's vegetation allowed, loads of different stuff. So my structure for points of interest is not complete yet, but it's good enough for me to get started. So in my point of interest struct, I have a reference to what is going to be the data asset, which is, if you're not familiar with PCG data assets are just point clouds that can include attribute data such as, static meshes, actor classes, position, rotation, etc. So this is where you will say what objects are actually in the point of interest. The next one is the maximum count. For start temple it'll be 1. Minimum distance from the origin of the world. Maximum distance from the origin, so this is how I can get our range. Minimum altitude and maximum altitude is just the height. The terrain delta is that slope we saw. Does it need a biome? And then boolean for must that biome be full? So entirely within the grid, is it entirely forest or is there some plains in that grid or whatever? Distance from other points of interest of the same type. Is foliage allowed? Center first, meaning when you're trying to place them, should you be trying to place them close to the world origin or not? And then the radius for which it can be placed. No, that's the radius of the point of interest. So how big is it? How much space does it take on the map? So that's the structure. And then if I open the data table, which is here, you can see I've made 4 examples so far based on Valheim stuff. So the start temple, which we can see, I said, there can only be 1. The max distance can only be 1. Altitude, this doesn't really matter because we're setting in the voxel graph the height of the world, and it's definitely between this amount. And we're also setting it to be very flat, so the delta is always going to be fine. The radius is the next other important factor. And then for things like boss shrines, said there can be 3, has to be within the first 100,000 units. Altitude again has a limit, so I don't want it popping into the mountains. Distance from similar must be fairly far. I don't know what I made as the asset for the meadow boss shrine. Yeah, and then radius and stuff like that. So that is how I am going to be creating the points of interest and scattering them in the world. And then on my BP PCG manager, ignore this outer and inner, this is for something I haven't yet put in a video, but it's to do with scattering foliage. I've added a third, in your case it'll be second, PCG component to the blueprint, and I'm creating a graph called Biome PCG. This one is just going to be generate on load, it's not going to be runtime. It's going to happen once when the world is generated, and then it's never going to happen again. Although in theory we could retrigger it if we'd had a patch and added new points of interest and stuff like that, but really you don't want to change a world once you've created it. So that is maybe where I'm going to stop. Am I, or should I show you quickly? No. Yeah, that's where I'm going to stop. The next video, actually, I'm not going to entirely stop actually. I'm changing my mind because this is a bit short. Let's open the Biome PCG and I'll give you a very quick overview of what's going on. So the actually, does it say it on this sheet? Valheim grids up its worlds into 64 by 64 grids. And when it's placing points of interest, it is essentially sampling those 64 by 64 grids, determining whether it's a full biome or not, and then looking to see if it can place some of its existing points of interest there. So a lot of this graph is figuring out how to determine whether a 64 by 64 grid is a full biome or not. Well, there's a lot more work that goes on in subgraphs when placing points of interest, but this big block here is about determining whether a biome has corners or not. So these create points. It could be one node, but I was really lazy when I was doing this. So it's just like going through all of the different variations of 6400, and I think eventually, what else do I do? No, that is it. I'm drawing 8 corners, 8 and the middle. So 9 points in a 64 by 64 square. A square and then a shifted diamond. So the diamond points are actually outside the square, but it also helps tell us whether it's a full biome or not. And then there's 1 point in the middle of the biome. So then all of those 9 points are merged, and I write the index of them. This video actually is the first video that uses PCG Extended Toolkit. This is a plugin on Fab. It's free. It will be needed going forward. It's a big plugin. It takes a long time to compile if you're compiling it from source. But just go onto Fab, type in PCG Extended Toolkit. It's by a good friend of mine called Tim, or Nebukam is his avatar, I guess, online. Download the plugin and get it installed. It's fantastic. It's got a load of tools for PCG that we will be using going forward. So get it. What I'm doing here is I am writing the corner attribute to these points. So the first point has a corner number of 0. Don't worry about it. I know a square should only have 4 corners. This is just a bit lazy terminology. But you can see we're covering a diamond, a square, and a rotated square, and then the center is corner number 8 apparently, but it's fine. I'm writing that onto this corner attribute, and then I am copying it around every 64 by 64 grid that is within our world. So the grid is, grid extents is set to be 1 million. I don't really need a grid height, because if you make this, say if you make the cell size taller, it'll become like, if you make the grid extent Z component taller, then it'll be a 3-dimensional grid. I don't want that. I want a 2-dimensional grid. My cell size is 64 by 6400, and the rest of it is fine. I am getting the distance of each of these points in this 64 by 64 grid. I'm getting the distance from the origin, and that is just so that I can cut out any that are below 750,000 units. That gives me, as you can see in the viewport, should have mentioned we're on 5.6 now, so we have a viewport in PCG, gives me a nice circle of 64 by 64 grids. And the reason I want that is that, we don't need to look here for points of interest. We only need to look in the circle, which is what all of that distance stuff was doing. So we get our called points grid. We're going to write the position to a location, to another attribute called cell location, so we can use it later on. And then we are copying our corners around each of all of these 43,140 64 by 6400 grids. That way every grid, I think these points all get their cell location as well. Yeah, so each of these corners now know which cell they belong to here, the cell location. And then we can gather them up later to check whether that square is a full biome or not. Then we're going to query the height and the color buffer. So we're going to get the color of the voxel terrain at that corner point. And we're going to use that color to tell us what biome it's in. I'm going to load the biomes data table, which again is the one that has just the enumerator value of the biome and the color of the biome. And then we're going to compare the colors of the query of our location with the color on the data table, so that then we can say what biome or what enumerator value this biome has. I think, to be honest, I could change that for text, but at the moment I'm just leaving it as the number of the enumerator. Then what we're going to do is we're going to partition the data into the corners. So we have a different pile of data for each corner, and what am I doing here? I am going to get the first attribute from each data collection, and I'm just going to get the corner number and append it so that I end up with an attribute called, or populated with the text corner 0 or corner 1. Add the text biome, I don't know if that's necessary, and then I am going to rename the attribute on the points to just say the corner name. So for each of these loops, instead of it saying corner 0, or well, I think before it just said corner, to be honest. No, wait, it said biome, didn't it? Yeah, but now I'm getting it the points to say corner 0 biome. And that's just what this little loop is for. It's a loop graph because it needs to do it for each of the corners that we've just partitioned into. And then we gather that. Do we gather that at the end? Not yet. Delete any unneeded attributes. So all we've got is the position of the corner, the cell it belongs to, the square, the big 64 meter squared grid it belongs to, and the biome that that corner is in. And then this node here, copy all attributes, is going to copy all of the results where the cell location is the same. So before this we have 8 points, but actually if you scroll through the different data collections, you see that they're also ordered by the same cell location. So this grid location here, its corner 0 is a biome 6, its corner 1 is a biome 1, etc. And what we're doing is we're copying all of these across so that we end up with, for each cell location now in our create points grid, we're back to our 43,000 points. That point gets given all of the 8 corner attributes, and then it knows what biomes are at all of its 8 corners. Again, corner is a bad term, but it's just the sample locations really. Biome modifier, bounds modifier, sorry. I set the bounds of the grid to actually have the 64 by 6400. I think it gets reset somewhere, because I'm sure it comes out of the create points grid with the correct bounds, and then I am changing it here, although I don't know if I'm fixing it, to be honest. So next we're going to use another PCGEx node, and this is called Uber Filter, and it allows us to set a load of different filters. So if I want to mark a biome as full, which is going to mean that all of the 8 points, so the square corners, the rotated square corners, and the center point, if they are all the same biome, I can then go to that 64 by 64 grid and say, yes, you are a full biome. And that's what this is doing. So this is really strange way of doing it, but it's comparing corner 1 to corner 2, corner 1 to corner 3, corner 1 to corner 4, etc. all the way down. And if all of those filters are true, then that point carries on through the inside. So we end up actually with 16,000 grids of 64 by 64 from our original 43. A third of them, bit more than a third, are full biomes. So I add an attribute saying this biome is full. I then sort it so that we see all of our meadows at the top. I don't really know why I'm sorting it, to be honest. And then we can partition it on any of the corner 4 or on any of the corner biomes, but I partition it on 4 for some reason. I think it's a carryover from when I was only doing 4 points at the start. So then we end up with piles of data, and what I could actually say is this is all of my meadows, full meadows, this is all of my full black forests, etc., because they've been sorted based on the order of the enumerator. And then I've got my reroute for full biomes, which I will use further down here when I am placing my points of interest. Now, I think that is probably enough for this video, just because placing the points of interest is its own battle. But this video has covered. Oh, it's so ugly when you zoom out. This video has covered how the structures work that I'm using for my points of interest, and how I am dividing up the world into chunks for placing points of interest. And the next video will be how to actually go through and place the points of interest. So thanks for watching. I'm hoping to get these point of interest videos through this week, and then I think I'm going to move on to foliage. I haven't decided what yet I'm going to do for foliage. I think I'm going to use Biome Core. So I'll probably also eventually link back to the Biome Core videos that I'm putting on my channel as well, on how to convert them into voxel plugin. And I'm working on the runtime video for that as well. Thanks for watching. Hope everyone has a good day, and I will catch you in the next video.